Welcome back to our channel for a new course. In this course we will make a small project using microservices. We will first talk about monolithic web application and microservices and compare them, and then we will use Laravel to learn how to make a microservice, and we will make a small project with it. First let's talk about monolithic web applications. What is a monolithic web application? Imagine you're building a big, awesome Lego castle. When you put all the pieces together to make one huge castle, that's kind of like a monolithic web application. In the world of web development, a monolithic web application is like a big, all-in-one kind of website. It's built as a single, unified piece of software, just like our Lego castle. Everything from the front end that you see on your computer or phone screen to the back-end stuff that makes the website work is all bundled together in one place. So, when do we use a monolithic web application in Laravel? Well, think about it like this. If you're making a smaller website or an application where everything is pretty straightforward and doesn't need to be split up into different parts, then a monolithic approach can work really well. It's like if you're making a simple game with just one level. You wouldn't need to build different parts separately, right? You can just put everything together in one piece, and it'll work just fine. So, to sum it up, a monolithic web application in Laravel is like building a big Lego castle where everything is in one piece. We use it when we're making simpler websites or applications that don't need to be split up into lots of different parts. Cool, huh? Now after we have talked and explained what is a monolithic web application and when to use it, we will talk about microservices. What is a microservice? Imagine you have a big Lego city instead of just one castle. In this Lego city, different buildings like houses, schools, and hospitals are all separate pieces that you can move around and change independently. That's kind of like microservices in web development. Microservices are like building a web application by breaking it down into smaller, independent pieces, just like our Lego buildings. Each piece, or microservice, handles a specific job or function of the website. So, when do we use microservices in web development? Well, let's say you're building a really big website or application, like a social media platform. Instead of building everything as one huge piece, you can break it down into smaller microservices. For example, one microservice might handle user authentication, making sure people can log in securely, another might handle posting updates, and yet another might handle sending notifications. Each microservice does its job really well, and they all work together to make the whole website function smoothly. We use microservices when we're building complex websites or applications that need to scale well and be easy to update and maintain. It's like having a Lego city where you can move buildings around and change them without affecting the rest of the city too much. Now let's compare the two. From the architecture. In a monolithic architecture, the entire application is built as a single, unified piece of software. All components, including the user interface, business logic, and data access layers, are tightly integrated. Microservices architecture breaks down the application into smaller, independent services, each responsible for a specific business function. These services communicate with each other through APIs. From scalability, scaling a monolithic application can be challenging because the entire application needs to be replicated to handle increased load. This can lead to over-provisioning and inefficiencies. Microservices can be individually scaled based on demand. Since each service is independent, you can scale only the components that require additional resources, resulting in more efficient resource utilization. From flexibility and maintenance, making changes to a monolithic application can be complex, as modifications may affect multiple parts of the system. Additionally, deploying updates often requires deploying the entire application. Microservices promote flexibility and ease of maintenance. Since each service is isolated, changes can be made to individual services without impacting the entire system. Updates can be deployed independently, allowing for faster iteration and innovation. Now from complexity, monolithic applications tend to be simpler to develop and deploy initially since everything is contained within a single codebase. However, as the application grows, the complexity can increase, leading to challenges in understanding and managing the codebase. While microservices offer greater flexibility, they also introduce additional complexity, especially in terms of managing communication between services, ensuring data consistency, and monitoring the distributed system. Now, from development team structure, monolithic applications may be developed by smaller teams since there is less need for coordination between different components. However, as the application grows, coordination and communication become more critical. Microservices often require larger development teams, with each team responsible for building and maintaining one or more services. Effective communication and collaboration between teams are essential to ensure the success of the overall architecture. In summary, monolithic web applications offer simplicity and ease of development initially but can become challenging to scale and maintain as they grow. Microservices provide greater flexibility and scalability but come with added complexity and require careful architectural design and management. The choice between the two architectures depends on factors such as the size and complexity of the application, scalability requirements, and development team structure. In the next video we will start to make our project using microservices and RabbitMQ. If you like this video and want to support the channel, check the Buy Me a Coffee link down below. Thank you for watching and see you in the next video. Now let's try and make our microservice using Laravel. First we will Docker and Laravel Sail, but what are those? Imagine you're building a super cool treehouse with your friends. You want to make sure everyone can easily help build it, so you decide to use some special tools to make the process smoother. Now, Docker is like a big toolbox that holds all kinds of tools you might need for building stuff. It's great because it lets you package up your treehouse project into little containers, kind of like little boxes that hold all the materials and instructions needed to build one part of the treehouse. But, here's where Laravel Sail comes in. Laravel Sail is like a super handy tool that's specifically designed to work with Laravel, which is like a set of blueprints for building your treehouse. Think of it this way: Docker is the big toolbox with all the general tools you might need for any project, while Laravel Sail is like a special tool that's tailor-made for building with Laravel. It knows exactly what tools and materials you need for your treehouse project and makes it super easy to get started. So, while you could definitely use Docker to build your treehouse, Laravel Sail makes the process even smoother and faster, especially if you're working with Laravel. It's like having a magic toolbox that knows exactly what you need for your project and helps you get it done in no time. Now let's install Laravel Sail. We will use this command to do so, and I already installed it on a new Laravel project because it takes a lot of time to be installed, and I already downloaded Docker from the Docker official website. After requiring Sail and then installing it, let's try and run our application. It will run with the port that we specified inside the YAML file. Now let's go and we will get the Laravel homepage. Now if we go to the Docker app, we will find everything Sail created for us. If you have any problems with the ports, you can change them in the YAML file. Now let's make our migrations. First let's delete the tables that we don't need, and then we will make a new table for our posts. We will use the PHP artisan make migration command create posts table. Now let's go inside of it. First we will need to add a title for the post, and then we need to add likes to know how many likes a post has, and then let's add, for example, an image. It is just a basic table just to test our microservice using it, so I will not add a lot of columns. Now let's make the post model using the PHP artisan make model command, and then let's go to the model and write our code. First we will specify the table that we have, and then we will add the fields like title, image, and likes. Then let's make a belongs to relationship with the user model, but we forgot to add the user ID, so let's add it in the fields and in the migration. And now the migration and model are ready, and we still need to create our posts controller. Let's make a new controller using the PHP artisan make controller command, and let's name it post controller. Inside of it we first need to make our index function. Let's just make it return all the posts that we have using the post model and the all method. Next we will need the show function. It will take the ID as a parameter, and then inside of it we will just use the find method and return the post that we found. Next we will need to make the store function. It will take the request as a parameter, and inside of it we will just create a new post using the create method and then return a response JSON that the post is added. Next we will need the edit function. It will take the ID as a parameter and it will just return the post that we found using the find method. Next we will make the update function. It will take the request and the ID as a parameter, and inside of it we will first find the post. If there is no post we will return an error message, else we will update it and return a message that the post is updated. And finally let's make our destroy function. It will take the ID as a parameter and then inside of it will find the post and chain the delete method to it to delete it, and then return a message that the post is deleted, and that's it for the post controller for now. Now let's go to our API routes to register our routes. We will use root resource to do so, and let's name our URL post, and then post controller. Next let's go to the Laravel Sail documentation. There is something we need. Instead of every time we write all of this to run the sail, we can just write sail up and it will run it. To do so we need to write this command in our terminal. So let's copy it and go to the terminal and write it. Then let's try sail up, and our server is running just like we want. Next we need to migrate our tables. So how do we do this? First we need to edit some things in the YAML file. First I have edited the MySQL credentials, and then I have added something called phpMyAdmin so we can connect to the phpMyAdmin, and I will explain it. Depends _on. This section specifies that the phpMyAdmin service depends on the MySQL service. This ensures that the MySQL service starts before the phpMyAdmin service, as phpMyAdmin requires a MySQL server to connect to. Image. This specifies the Docker image to be used for the phpMyAdmin service. In this case, it's using the phpMyAdmin image, which is the official phpMyAdmin Docker image available on Docker Hub. Environment. Here, you're setting environment variables for the phpMyAdmin service. PMA host equals MySQL specifies the hostname of the MySQL server that phpMyAdmin should connect to. Since Docker Compose sets up a network between services based on their service names, MySQL refers to the MySQL service defined in the same Docker Compose file. PMA port equals 3306 specifies the port on which the MySQL server is running. The default MySQL port is 3306. Networks. This section specifies the networks the phpMyAdmin service should be connected to. In this case, it's connected to the Sail network, which is also used by other services in your Docker environment. This allows phpMyAdmin to communicate with other services, such as MySQL. Ports. This section specifies port mappings between the Docker host and the container. In this case, port 8002 on the Docker host is mapped to port 80 within the phpMyAdmin container. This means you can access phpMyAdmin from your browser at localhost 8002 overall. This configuration sets up a phpMyAdmin service that depends on a MySQL service, configures it to connect to the MySQL service using the specified environment variables, and exposes phpMyAdmin on port 8002 on the Docker host. Now let's go to the phpMyAdmin and try to access our database. We will go to localhost port 8002, and then write our username and password. And we are in. Next we will use the Sail artisan migrate command to migrate our tables, but I have already did that when I was testing it. Now let's make our main Laravel app. I have created a fresh Laravel project and named it main microservice. Now let's require the necessary packages. We need to first require Sail, so let's go to the documentation and require it. We need to use php artisan sail install command, so let's do that. After it has installed, let's add some things just like the admin project. First we need to add the phpMyAdmin configuration, and then we need to adjust the database credentials, and we need to edit the ports. And after we have done all that, let's run the sail using the up command, and we have an error. Let's run our Docker first and then try again. And now we got a new error from the ports. We forgot to edit the app ports, so we have edited it, and now let's try again. And our server is running. Now let's go to the phpMyAdmin to access our database. And let's put our credentials. And we are in, and there is a database called main.db. Now let's migrate our tables. Let's open a new terminal and run the migrate command. And our tables are migrated and everything is working just like we want it to. Now we need to make our migrations inside the main app. We will make the posts table using php artisan make migration command. And then inside of it we will first edit the ID because we don't want it to be an auto increment, we want to take it from the admin app, and then we will add title and image. Next we will make the post model and post controller. Now let's go to the post model and add the table and fields. Next we will go to our post controller and make only the index function for now. To test everything with it, next we will go to our root to register the index root, and now our main app is ready. Next we need to use a tool called RabbitMQ from this website. But what is RabbitMQ? RabbitMQ is an open-source message broker software that implements the advanced message queuing protocol AMQP. It provides a robust messaging system for building distributed and scalable applications by facilitating communication between different components or services. What are the key features of RabbitMQ? RabbitMQ allows applications to communicate with each other asynchronously via messages. It enables decoupling of producers, applications that send messages, from consumers, applications that process messages, which improves scalability and fault tolerance. RabbitMQ uses message queues to store and route messages between producers and consumers. Messages are placed in queues by producers and consumed by consumers when they are ready to process them. In RabbitMQ, messages are published to exchanges, which then route them to the appropriate queues based on routing rules defined by bindings. Different types of exchanges, e.g., direct, topic, fan-out, provide different routing mechanisms. RabbitMQ supports message durability, which ensures that messages are not lost even if the broker or consumer fails. It achieves this by persisting messages to disk and replicating them across multiple nodes in a cluster. RabbitMQ provides a management interface and various monitoring tools to monitor the health and performance of the message broker. It offers features such as message tracing, metrics collection, and fine-grained control over queue and exchange configuration. Overall, RabbitMQ is widely used in distributed systems, microservices architectures, and cloud-native applications to implement reliable and scalable messaging patterns for inter-service communication. It offers a flexible and feature-rich messaging platform that can be adapted to various use cases and deployment scenarios. To use RabbitMQ, we will use this package that is called Laravel RabbitMQ. Let's copy the require command and go and use it in the admin and the main application. Next, after we have installed the package, we will need to add its configuration. Let's add them to the config queue file in the main and the admin application. Next, we need to use our credentials inside of them, so let's go to the RabbitMQ and take the data that we need and paste it in the queue file. It is a better practice to add them in the env file, but for now I will add them here. It is a free plan, so I will show you my password and my credentials, it's fine. And after we have added everything to the admin and main application, we need to test everything. To do so, we will use commands and jobs. Let's go the admin app and make a new command. Let's call it test command, and we will make a new job and call it test job. Inside the command, we will name it test command. And we will use the dispatch method for the test job that we created. Next, we will go to the main application and make a new job and call it test job. Then we need to go to the event service provider in our main application to catch the event that we will fire from the admin app. To do so, we will use the app bind method, and inside of it we will use the test job that we just created, and a callback function to return the job handle that we will write. Now we will go to our test job, and in the handle we will just echo a message, event has been handled. Next we will run the queue using the command php artisan queue work, so we can run the queue and wait for events. Next we will go to the admin app and run the command using the command php artisan and then the name of the command. Now after we have run it, let's go to the main app, and we got our message. Now if we go to our RabbitMQ page, we will find that there is a message from the graph. So now our RabbitMQ is running and everything is working just like we want. Now after we have fired our first event and everything is working fine, let's go and make events for all the CRUD operations that we have. First let's make the post creation, so let's make a new job in the admin app using the php artisan make job command, and then let's go to the post controller to add the job dispatch line to the store function. We need to pass it the post as a parameter so we can pass it to the main application. It is always a good idea to make it into an array, to let's use the toArray method to do so. Now let's go to the job we created and add the post into the construct method, and let's call it data. Now let's go to our main app and make the job. We will pass the post in the construct method also, and after that we will make the handle function. Inside of it we will create a new post using the post model and the data that we have. After we have written the handle function, let's go and register our event in the event service provider. We will write it just like the event we wrote earlier, and that's it for the post creation process. Now let's go and test it. But first we need to edit a few errors that we could have in the admin app. We wrote the fiable wrong, we added an S to the end, and let's only keep the title and image, we don't need anything else. Then let's use the Sail artisan migrate fresh to refresh our database. Next, in the main app, let's also remove the S from the fiable and migrate the database, because we forgot to do so when we made the posts table. Now I have edited some port and environment variables in my env file and my YAML file, because I had some problems with them. Now after I have run Sail using Sail up on both of our apps, let's run php artisan queue work on the main app. Now let's go to Postman and add a new post using the API posts route that we created previously, and we got the message post is added. Now let's see our main app, and the job post create is done. Let's go to our main app database and we can see our new post is added and everything is working just fine. Now let's try the delete method. It will be just like the create method. First we will make the job for the admin app, and we will add the data to the construct method. Next, let's make the job for the main application, and we will add the same data to the construct method, and in the handle method we will find the ID and delete it using the delete method. Next, let's go to the post controller to add the job dispatch to the destroy function in the controller, and we will pass it the ID. We forgot to add the this to the handle function in the job, so we will add it and then add the job to the event service provider just like the create job. Now let's try it. We will go to Postman and add the ID in the URL and try to delete it. And the post is deleted. Let's check our databases, and the post is deleted. And the job is done. So now the delete job is working just like we want it to, and that's great. And that's it for our course. We created a simple microservice and communicated between our admin and main application. If you have any questions, add a comment down below, and if you want to support the channel and buy me a coffee, check the links down below. I will upload the project to GitHub and add a link for it. Thank you for watching and see you in the next video.